I was just going to do that now. So everyone's probably seeing something pop up that's saying we will start recording.
Sweet. All right. Great conversation so far, and thanks, Jason, for getting this organized. For folks who don't know me, my name is Matt Lurie, and I'm the Shoreline Armoring Implementation Strategy Lead with WDFW, supporting the Habitat Strategic Initiative Lead, or HSIL. And I'm thrilled to help introduce today's webinar focused on several of our programs investments in shoreline monitoring projects in Puget Sound. And I would really like to thank the PSEMP Nearshore Work Group for hosting and just doing a lot of work as partners in general. Next slide, please. A little bit about our team. HSIL is an interagency team supporting the National Estuary Program, co-led by the Washington Department of Fish and Wildlife and the Washington Department of Natural Resources. Our focus is on advancing Puget Sound recovery through collaborative planning and strategic investments. We award grants with Puget Sound geographic funds through a cooperative agreement with EPA in support of the Puget Sound Action Agenda and implementation strategies. One of the reasons this is really exciting is because the dollars that we award go towards traditionally difficult to fund actions that catalyze greater opportunities for recovery. Next slide, please. The project you will hear about today directly advances the Shoreline Armoring Implementation Strategy, which addresses a legacy of hard armor installation along Puget Sound shorelines. And this has many ecological impacts and often does not adequately protect property as intended. Of course, if you're keeping track at home, the strategy is very closely aligned with the Action Agenda Strategy 3, Healthy Shorelines. The implementation strategy's goal is to reduce the impacts of shoreline armor so that biogeophysical processes are not impeded, including the supply and movement of sediment. This, of course, will hopefully improve the function of nearshore systems and provide the habitat necessary to sustain a diverse and resilient marine food web. And then a functioning nearshore also provides beaches for recreation and protection of properties by the natural replenishment of beach material. Next slide, please. I'm so really excited. The project that you're going to hear about today from Jason Toft and Jason Morgan and their teams directly advance outcomes within the coastal-based design and technical training approach within the Shoreline Armoring Implementation Strategy. The shoreline monitoring protocols, the public engagement, the critical analyses, and the easily accessible databases really help increase regional technical capacity and knowledge on our shoreline armor removal and restoration projects. And I have the pleasure, and I'm very excited to preview that HSIL is continuing to fund another phase of this work. So huge congrats to the project team and the partners and the public who've worked on this. Next slide, please. One more note is that if you want to get more information about our program at HSIL, please visit our webpage and you can subscribe and get updates. And we just announced a large list of recent investments to enhance Puget Sound recovery goals. And so you can see the full list there, and I will drop that in the chat as well for folks that are interested. So I think now I'll pass it back to Jason and Jason. Looking forward to the talk.
Let's see. All right. Thanks for that introduction, Matt. And man, it is so exciting to see all of the projects that are being funded with HSIL. If folks haven't had a chance to look through that, really do. It's just really a really great investment. Okay. So moving on, you'll hear from the team that's worked on the shoreline monitoring database for the last few years. And it really is a large team effort. You can see on the right the main people who have worked on this the last few years, and within each of our organizations, you could probably list another 5 to 10 people as well. It's just been a really great group to work with. And for this talk today, you'll hear from a few of us. You'll hear from the two Jasons there, as well as Simone at UW here, and Bianca at the Vashon Nature Center, and Jen Sherrill at Sound Data. So we'll kind of bounce back and forth in making our way through the slides. Again, a huge thanks to past funding to get us to this point, and it's really exciting to be kind of at this, bridging the gap here between past funding and future funding, and we're really looking forward to the future. Okay, last thing I'll say on this slide is you're going to see this shoremonitoring.org quite often throughout our talk, and that is really where a lot of this material is centered at, and so feel free to check that out at any point during our talk. We won't be offended if you go there to look at things. Okay, a few introductory slides, and really the talks preceding in this work group meeting have really set the stage for a lot of this. So again, a large part of why we're doing this is to look at effectiveness of restoration. And in the case of this project, shoreline armor removal has been a huge emphasis of this. And so you can see some photos here at Sierras Park of what this section of beach used to look at with armor. And then the middle slide, the middle photo there is when it was after it was just restored. And then the photo on the right is a number of years after restoration. And so you can see visually at some of these sites, you can see progress happening. And what we're really trying to address is what is the functional response at these types of sites. And so we started working together years ago on trying to just come up with protocols on how to measure success of these sites and see how effective they are, and really trying to just spread out and gather a lot of people from different areas in the Sound and work together. And there's been a lot of great projects that have built over the years around this and really helped bring this into focus. And Matt mentioned the Shoreline Armoring Implementation Strategy. The Marine Shoreline Design Guidelines have a lot of the design features we look at with armor removal. And you can see in the center photo, there's often placement of logs and planting of vegetation and what's called sediment nourishment, so bringing in additional sediments to the beach. And then one more other great group to mention is shorefriendly.org. And so just getting the word out to different audiences, especially landowners, on what can be done at beaches and what the functional response is. Okay, so we like going up to beaches, and this is a photo up at Bowman Bay in Deception Pass State Park. And it's been really fun to work together at these beaches. Instead of any of us in our own groups going out to a beach, we get to meet other people. We get to meet volunteers in the community. So there's a large community scientist engagement that Jason Morgan and Bianca will talk more about. And so reaching out to community scientists, nerdy academics like myself, and then agency folks as well, really trying to work together so that we can say more about these beaches. Okay, so what does it take to get from being on a beach in the field to get to this when you get to sit at your computer and try to figure it all out? And that's really been the last slide, and this slide is what we're trying to do. So not just going out and using the same protocols at beaches, but what do we do with that data? How do we bring it into a centralized framework where all the data gets combined together, and you can press return on your computer a lot and say really cool things, and also having online visualizations and other aspects so that people can access the data, they can look at what it's saying, and then it's up to us as well to analyze and interpret that data so we can have this cycle back to designers and management so that we can plan for the future and how to restore beaches in a more informed way as we move on. Okay, so with that, I'm going to hand it off to the other Jason Morgan, and he'll talk for a few slides.
Yeah, thank you, Toft. So I'm just going to give a kind of a bigger picture overview of what this project is and what we've accomplished. So it's a combination of two NTAs. So the first one is Shoreline Restoration Effectiveness Monitoring, and that one, the Northwest Straits Foundation, our organization, was a lead on this, but with all those partners that Jason Toft showed on his slide. And as he mentioned, those were like our main partners running this project, but then we had a lot of other partners, particularly volunteer organizations, that helped us get a lot of this work done, including the Skagit Island, Whatcom, and Jefferson Marine Resources Committees, Friends of Saltwater State Park, Soundwater Stewards, Sea Stewards, and I'm probably missing a couple other ones there, but it's a really big collaborative effort. And what we want to do is produce a robust data set that demonstrates the ecological benefits of shoreline arming removal. And we want to recruit, train, and employ citizen volunteers. It's a lot of work to get done, and we really can't do it without our volunteers. Prior to this funding opportunity, it was really hard for us to find funding to do monitoring. And so we were kind of piecemealing it together, each of our own restoration projects, kind of year by year, we were finding money to do surveys because we want to monitor our own restoration projects. And this is the first time that we were able to get kind of long-term funding and be secure and be able to do something with that. And also prior to this, because we're kind of piecemealing that funding together, all that funding will cover would be just enough money to go out and do the work. So we were collecting this data that was just kind of sitting there and not much being done with it except for general summaries. So it enabled us to also have the capacity to do something with this data. And that's kind of where the Shoreline Monitoring Toolbox came in, which is now evolved into an awesome database. At the time it started this, it was just a toolbox. And so because we were doing this with so many organizations around the region, one, we needed somewhere to put the data and we needed somewhere to work with the data. And so partnering with UW and Sea Grant on the shoreline monitoring database was a easy fit because we were already working and partnering together as is. Oh, sorry. Next slide, please. I'm trying to change slides over here. And so I'll show a map of where all these sites are, but it's a lot of sites all over the Puget Sound region. So this study is representative of our beaches all over the Puget Sound region. It's also representative of the different shore types that we have. So we study transport zones. This is Howarth Park on there, accretion shore forms like Cornet Bay, feeder bluffs like Maryland Point, and pocket beaches like Bowman Bay. Next slide, please. So some things that we accomplished, we surveyed 28 sites throughout the Sound. Some of those sites dropped off because different issues like access and restoration projects not happening. So 23 of those sites were surveyed consistently throughout the project and are still being surveyed now. We've done some good things with the data that'll be talked about later on in this presentation by my colleagues. We produced a case study report. 2 published manuscripts. I have an asterisk there because we published a manuscript last year, and we are just putting the finishing touches on one that's going to be submitted for publication here pretty soon. And we've also conducted 10 presentations throughout the region to different user groups, including you guys, the Salish Sea Ecosystem Conference, volunteer organizations. So a lot of people that we're reaching out to. Next slide, please. Tried it again. In our volunteer engagement, we trained over 100 volunteers and got over 2,700 volunteer hours. So that's a lot of work and a lot of help. So obviously that we just couldn't do the work without them. That's a lot of power there. But also another big benefit of that is that these volunteers kind of naturally become advocates for the work we're doing. They always learn a lot on the job with us, and then by nature, now they're going and talking to their community members. So they really help us not only with doing the work, but also with that outreach component. So it's really exciting to get our community members, both kids and adults and retired folks, all out in the field with us. I believe that's my last slide, Top, is it? Yeah.
Yes, passing the baton to Bianca.
Okay, thank you. Great overview, Jason. I'm going to do a little zoom in and give you a little feel for what one of these sub-projects looks like. This is Vashon Island. We are situated in the south portion of Central Puget Sound, and we have grown from 3 monitoring sites in 2016 to 7 that we're monitoring now. We monitor with our BeachNet program, which is a community science program of volunteers. BeachNet stands for Beach Nearshore Ecology Team. And we have over 200 volunteers signed up on the list, and then we make teams out of that volunteer list to come to the beaches with us each summer. And our volunteer ages span from about 16 years of age to about 80. And last year we completed 400 and 60 volunteer hours, and total through this whole timeline from 2019 to 2022, 864 volunteer hours on Vashon to get these sites monitored. And that was during the COVID span as well. So we had some good volunteer efforts going on because these are nice outdoor sites. Okay, next slide, please. So I just wanted to show some visual highlights of what we're seeing over time. This is our Big Beach site. And you can see before restoration on the left, and then 1 year after restoration. We have taken armoring off many high bank sites, which is a little bit different than some other low bank sites. And so it's kind of neat to see the amount of change that happens on these sites. You can see big slides happening here. And we're getting a lot of movement when those bulkheads come down and a lot of sediment deposition. And the other thing that's interesting that we fell into by accident, we are doing a totally separate wildlife camera study with Olympic Cougar Project on Vashon. And we had a grid set up last summer and noticed that shoreline sites get they get probably the most visitation of all of our sites on Vashon with the most variety of animals. And these high bank sites that slide, especially if they slide to the angle of repose, they provide connectivity for these terrestrial animals like deer and coyotes. Otters use them to get to and from the beach and go between the beach and the upland areas. So that's kind of an interesting thing we're going to hopefully look into a little bit more in the future. Okay, next slide. Another thing that we notice a lot here on the island, we are a rural island. We have a lot of forested land. This is our Tahlequah restoration site on the south end of the island. Left is taking the bulkhead down. You can see in the middle, there were some anchor logs that were placed as part of the restoration. And then you can see a year later, all of the wood that came in. So we get a lot of natural wood recruitment at our sites on Vashon because we're surrounded by the Kitsap Peninsula. This particular site is across the water from Point Defiance Park. So there's a lot of wood in the drift cell system here that leads to this recruitment of wood. Okay, next slide. In terms of volunteers, I think this is just a really cool part of the story. We discovered pretty early on that this type of community science is great for youth engagement for high schoolers. You can see that lower middle there, Jason Toft comes out and his crew to help us with a beach survey every year for the 9th grade biology class. So that's 26 students that help us monitor a site. And it's great because we can use this as part of their curriculum. They get really excited about being on the beach for the day, and it's a handleable data collection with in terms of their attention span, and with supervision, it works really well to have these kids on the beach helping us collect data. They get really into it and they get to know their island better. We also have in the past worked off of this to also offer opportunities for youth engagement for the summers, because most of our kids are out of school in the summer, and so they are able to help us on the beach for these surveys, which has been great. We also have now a marine science internship program where we actually offer paid internships, and some kids also come and get their community service hours checked off with us by doing these surveys. And we have a lot of crossover and continuation where kids just stay in the volunteer pool after the summer and help us with the forage fish surveys. And that's what you see up in that center upper photo here, is because they happen at night, so the kids can do them after school. So lots of youth engagement, which also trickles to families and when the kids talk about what they're learning on the beach at home. So that's been a really great development in this program that we're really excited about. And I didn't tell my team this, but we also just got interest from a math teacher at the local school to see if he could use the Shoreline database data in his math class. So I might have him reaching out to you, Simone, to talk about possibilities with that. And we just got interest from Seattle University to see if some of their students would come out and join us on the beach. So lots of ages appropriate to collect this data, and a really great way to engage people on the beach. And that's all I have.
That was all great. Thanks, you two. I love it when I learn things related to all this during the course of a presentation myself. So, okay, so going out on a beach and bringing it back to the online database now. And so part of the goals of this part of the project were to expand the number of protocols we have up there, provide data upload and download capabilities in this centralized format, and also have some data visualizations up on the website. And I'll speak some to the next few slides, and I'm hoping Jen Sherrill will pipe in as well, because it's really her team that is doing all the magic. I mean, we are not, people like me are not trained to like do websites, right? And like to get these massive databases together, and you really need experts to do that. Jen, would you like to chime in about kind of the database and visualizations at all before I start rambling?
Yeah, I would love to. Thanks, Jason. This has been such a fun project for my team. I want to acknowledge Kira and Sky, who are the web developers who have been working on this. We really love the work, and it's so rewarding and satisfying to get to see these collaborations that everyone has built and all of the work going on the beaches, and to get to kind of help facilitate all of that by building a website to bring it all together, and to hope, our goals were really to make it a really low barrier to access, that we wanted the website to be really welcoming, somewhere that all kinds of people can come, from the scientists to the first-time volunteers, and feel comfortable interacting with the resources here. And then automate, to compile all the data coming from all these different sources into a single data set that can get used in various ways, and have that all happen automatically, so that it frees up Jason's time and the rest of the team to be doing interesting science and to be out on the beaches doing the work. So I guess that would be the introduction, I would say, for the website itself. We started by, first we built the protocols. Built the website to display and to make accessible the protocols. And you'll definitely notice here, we have some beautiful artwork that we have been able to work with in building this website. And I want to give thanks and acknowledgement to Simone for, she has hand painted tiles for every one of our protocols that you see here on this slide, which make it really fun to build a website around some pretty amazing art. Jason, did you want to add to that? Yeah.
That is great. Thank you for that overview, because I couldn't say what you said. This is, again, the part of the great team. All right, so let's move on to the next slide. But for folks who want to go to the website, you'll see that there's 11 protocols have these database features. And we thought about going to the website at this point, but we're not going to. We're just kind of going to give a couple snapshots of what you could find out there. So there's a protocol landing page for each one, and I'm showing you here the logs protocol. And there's an overview, there's a one-page protocol, so that anyone can have access to how to survey for logs in this case, and a field data sheet. And then you'll see some other components there on the left. There's a database map and visualizations that we'll go into a bit more. For example, here's the visualizations, and it's been very educational to figure out what it takes to get a raw database and get it distilled to get to this point. Simone has done tons of work on just getting all the names to work with each other in the file, and Jen and Kira and Sky behind the scenes on really making this happen. And so the visualizations that are up there are based on the raw data that's uploaded to the database. And so this is a really first good display, we hope, on what's in there. And then for anyone who wants to be a nerdy scientist and download the data and really analyze, using statistics and whatnot, then that's an additional option that obviously takes a lot more work to get to that point. But we want to provide something initially for users to be like, okay, what sites are in this data set, you know, what kind of material. Okay, one more feature up on the website is a map. And so just displaying everything that's out there. And there's a lot of information here, but, you know, briefly, the blue points on the map are sites that someone is monitoring for restoration effectiveness. So sometimes it's us, sometimes it's someone else. And this was based on past work from the PSEMP Nearshore work group on building just a list of sites and details about those sites. So we can know where those locations are. We know some details such as year of restoration, length of armor removed, and then all the other various points you can separate by different protocols and see where anyone's been sampling. Okay, so kind of a lot, and let's move into analysis and interpretation, but I did, Jen, want to give you one more chance. Is there anything else you'd like to say on kind of that database component or kind of where we hope it to go in the future?
Yeah, I guess just that we're looking to add database components for the rest of the protocols coming up, and that's going to be really fun to do. So we'll have database features, hopefully for all 20 protocols. And then it's been really fun as the site has been live and you have the seasons of fieldwork, the data keep coming in and compiling and growing. And it's really, I thought it was really great to hear the ideas of new people who are wanting to look at the data and participate in adding to it. But we're just happy to be able to provide this kind of real-time data processing tool to help facilitate all the rest of the good work going on.
Great. All right, so we're getting into the kind of final chapter of this, and that's looking at analysis and interpretation. And recognizing it is 10:50, we'll hold your attention here for another 5 minutes or so, and just give you some snapshots of the analysis. And so one publication is out there in variability, and then we'll talk about some analyses we're finishing right now, dealing with, it's all dealing with restoration effectiveness, but bringing in other variables such as shore type and fetch, what types of restoration action, length of armor removed, and time since restoration. And Simone, would you like to chime in on this slide? And Simone's talked about this before in the past, but we thought we should give at least one slide on this already published material.
Sure, yeah. Thanks, Jason. So this was a publication we had out last year. And basically, in general, what we found was that we had a lot of variation from site to site in terms of all of our different protocols. And this variability was really most pronounced in our natural or never armored sites and getting up there in our restored sites as well. Whereas our sites that had armor kind of compress this natural variability. So kind of the take-home message for this paper was that armor doesn't only reduce the abundance or the amount of these different response variables like the amount of rack or the number of logs or abundance of insects, but it also decreases the variability from site to site. So that was kind of the main take-home message there. Trying to be as fast as I can. Is that good, Jason?
That is great. And again, Simone's talked about this in the past, and people can check out the publication online. To go towards what we're working on now, finishing up in March, we'll detail just some snapshots of this analysis. And what I'm showing you here is a map, obviously, of different sites around the Sound. And with this analysis, we wanted to pair restored sites with natural reference sites. And those two would have the same shore type. So for instance, you know, two feeder bluff sites, one restored, one natural, close to each other. And so we can see not only measuring restoration effectiveness, but how different shore types feed into that, and also bring in other variables such as fetch. When you have a short fetch versus a large fetch, how does that energy, how might that energy affect the restoration responses that you see? So I'm just going to show you 2 slides of some emerging data. And the one on the left here is count of fallen trees. And so looking on the horizontal axis here on natural and restored sites again, and the colors are different shore types. And you can see two things in this graph. One is that overall, we found more counts of fallen trees at natural sites than restored. Kind of makes sense. Trees take time to grow, right? And so you might think this is a component initially that would be higher at natural sites. We also found that feeder bluffs had a higher count of fallen trees than the other shore types. And again, it's great to like see this data and think about it and like, okay, that makes sense. You know, when you have erosional bluffs, they're providing sediment to the near shore, but there's also other riparian material that comes down with that. And then looking over at log counts, there's other metrics that basically show no statistical difference. So in this case, in log counts, so driftwood coming into the site and being deposited on the ebbing tide, we didn't see any statistical difference in natural or restored sites or in the different shore types. And so that's great to know. It means that in this metric, restored sites have been effective at approaching natural conditions. And it seems pretty consistent across our different shore types. Okay, one more slide on this analysis is looking at fetch. And again, this is the benefit of having a bunch of different sites together. The one on the left is rack depth. So when beach rack, algae, eelgrass, and leaves are deposited on a beach, we measure the depth of that. And you can see there's a pretty clear line here of rack depth increasing along with fetch. So when you have a more exposed site with a lot of wind energy coming in, you're getting a lot of input of this beach rack coming in and being deposited on a beach. And conversely, we found the opposite effect with proportion of surface sand. So looking at what's on that upper beach and percent of sand, we found more when there's low fetch and sand going down when you have increased fetch. So again, in sites where there's low shoreline energy, that sand is better able to stay on the beach versus when you have a lot of wind and waves, it seems to be washed away more. So just two kind of snapshots of where this data analysis is going. And now I'll hand it back to Simone for a couple slides on these other characteristics.
Thanks, Jason. So these results I'm going to show you are really hot off the press. Basically, I've been analyzing this stuff in the last few weeks, and I feel like I'm always saying that, and it sounds exciting, but really it's because I'm like behind on everything. Just kidding. Anyway, so I was looking at different characteristics of restoration in terms of the length of armor removed and also additional restoration actions. So Jason mentioned those earlier. That was native vegetation planting, placement of logs, and sediment nourishment. And these are basically things that are done post armor removal. And then everybody always asks this, what is the effect of years since restoration? So I also looked at kind of the timing since restoration. Next slide, please, Jason. Oh dear. We have lost our bars here somehow. Okay, well, I guess I can explain these results without the actual results there. There should be bars here, and I'm not sure why they're not. You could just see the error bars. So basically what we are not seeing here is different groups of amounts of armor removed and 3 different response variables. And compared to kind of a before or pre-restoration condition. So in terms of number of logs, basically before removal, we have the lowest number of logs, and then we see a steady increase with the amount of armor removed. So this is kind of a positive relationship. You can take my word for it. The next slide, or the next one in the middle, is basically looking at the amount of rack cover. And in this case, we have, basically showing that the amount of armor removed is not of that much consequence. It's just that armor is removed in total. So before removal, we have lower rack cover, and then after removal, regardless of the length of armor removed, we have higher levels of rack. And then we see a kind of an interesting, unexpected pattern that I can't quite explain with insect abundance, where again, we have low levels before removal, but we see this jump in insect abundance for the lower than 200 feet of armor removed. So that's something we have to look into in a little bit more detail. Next slide, please. I'm now worried. Okay, we got this situation again. Okay, so with this, in this case here, I'm looking at different restoration actions. In this case, it's this action is logs added, so post armor removal. The addition of logs turned out to have really big effects on a lot of our different response variables. So as you can sort of see here, when logs were added in addition to armor removal, that's when we see increases in the proportion of surface gravel, of course, the number of total logs, proportion of rack depth or rack cover rather, and the amount of supertidal vegetation. So you can see that the addition of logs actually increases these things over and above just the removal of armor. You can sort of see that. Apologies, I can probably send around these slides later or something so you can actually see the results. Next slide, please. And these are missing some too, but that's okay. You can kind of see these trends here. Here we just have years since restoration on the x-axis and a couple of response variables on the y-axis. We have rack depth on the left-hand side and total insect abundance or invertebrate abundance on the right-hand side. Interesting here, we see that when we only remove armor, we don't see that much change in the amount of rack or rack depth through time. Whereas when we add logs, we actually see an increase in the mean depth of rack through the years since restoration. So that's kind of an interesting interaction with time. And then we have this kind of surprising result here on the right where we see total abundance of invertebrates increasing through time when we only have armor removal, but not actually changing that much through time when we have vegetation planted. So this is kind of an interesting result, and maybe because we have natural recruitment of vegetation in the armor removal only situation. So I'm going to leave it there. Apologies for those slides not looking correct. I'm not sure what happened there, but trust me that there are actual data there. Thanks, Jason.
Thanks, Simone. Yeah, and of course, all this material we'll provide here as we get the reports finished up. Okay, we've talked up until 11 o'clock. Good job, us. So I'm gonna stop us from talking. We have some next steps coming up, and please check out the website for more information. And I know it's 11, so as folks have to go, I'm sure they're already leaving. And we are happy to stay on though and have any questions if anyone has them. Yes, Tish, your hand's up.
Great presentation, all of you, and just love seeing the results. Totally interpret them without the full bars. So appreciate just taking a look. I was wondering with respect to the additional actions, just to clarify, that's with armor removal, like where it's an additive or a.
That's right. Yeah.
Okay. Yeah. That makes a lot of sense. I just wanted to make sure it wasn't those actions only, which would be another. Would have a different interpretation. And then the other thing I was just thinking about was the increase in insects at just the small sites, and what I'm sure you guys have already thought this through, but just thinking about whatever is adjacent to the armor removal site is maybe being particularly influential in that, in those sort of small cases in a way that I don't know if we always think about. So just really, really great to see this work coming together.
Cool, thanks, Tish. Yeah, and of course, there's a lot of other landscape variables we hope to address in the future. As we get more sites and more years of data, we can hopefully answer some of these broader questions too on just how much vegetation is in the area, questions like that. Okay, since I've been speaking a lot, I'm of course have not paid any attention to the chat, and I know we've run over our time. Paul, I see your awesome comments, if you're still there, on putting all the pieces together.
Yeah, I was just going to say, I think that there's a huge focus on restoration effectiveness, and I'd be really interested in expanding that to include regulatory information about the difference between damaged and natural shorelines, or how, especially around, there's a huge area of sort of information gaps there where there's really not a strong advocacy group for, because the regulatory community doesn't have the capacity to think.
I would love to talk about that more. Do you want to talk to all of us sometime in the future here as we start our next project and see if we could build something in to try to address that down the line?
You betcha. That would be great. And I think it would be part of, I think, the science sprint wrap up too, is what we kind of learned by trying to interact with the regulatory community around science synthesis. I think was really eye-opening in terms of sort of what the regulatory process looks like, the kind of information they need, and then how that information flows or doesn't flow from scientific practitioner communities.
Yeah, and I know you mentioned that in the chat a long time ago now. With your science sprint effort, it sounds like that part of it has wrapped up and you're going into the next steps now.
Yeah, we finished, we're trying to finish the beach nourishment. We actually hit a target. We actually provoked a regulatory response through a science synthesis, which is slowing down the paper review process, because now all the regulators are scrambling to figure out what to do with the results. And then the next round is going to be focused on non-natal use of shoreline by juvenile salmonids. So again, no new data, just science synthesis, gathering all the evidence that's piled up and trying to make sense of it and sort of organizing, looking for gaps. What do we know? What do we don't know? So if you have any unpublished or hard to find information about how juvenile salmonids benefit from shorelines, there's a lot of density data, but the sort of bioenergetic stuff is harder to track down and find. So you can talk to me or Max Lambert at DFW, who's the laboring oar on this, or Josh Chamberlain at Fisheries Science Center. So trying to get towards this variable benefit sort of landscape along shorelines.
Yeah, it's also interesting, and I don't know, being at the starting point of this next round of HSIL funding, we want to answer all the questions, right? But we can't. So I don't know. I think certainly with your sediment nourishment, when it's finalized, we should read that report closely and see how we could build from it. And I don't know, we do have a fish protocol for snorkel surveys up on the database, which is awesome to get at least behavior of fish, not just density. So maybe down the line, if there's any more work to be done at embayments, we can just see how this work progresses.
I was wondering about fish, like how hard it is to get high quality fish use data in submerged aquatic vegetation, just because of just the surveying challenge of being able to find them and know if they're there or not without destroying everything.
Yeah, I mean, that's a whole nother 2-hour meeting.
Yep.
So dive surveys, I guess, but
Yep.
There's a lot there.
Yep. Anyway.
Okay, it's 11:07. That was just a packed meeting, everyone, and thank you for those of you who have stayed on. Is there anyone else from the database team that has any final thoughts, or if I missed a question anywhere?
It's an extraordinary effort. Thank you, guys.
Okay, we should probably move on. Matt, is there any last thing you'd like to wrap up from HSIL's perspective?
No, we're stoked to keep this going, and as we develop scope of work, we can kind of incorporate some of the the feedback they're getting now, and as you said, there's a lot of good work to do. So we're just pumped, and thank you to everybody for the the effort that you do. This is just amazing.
All right, good vibes all around.